Hi class, welcome to this presentation on statistics. Specifically what we're going to look at is a branch of statistics called descriptive statistics. These are probably the easiest stats to understand as they typically just convey basic information about a population or a group of individuals in a sample, but doesn't necessarily make any inferences or doesn't test for significance of these numbers. So basically are things like percentages, averages, means, etc. So in this presentation, what I hope to do is go over some of those key concepts so that we can better understand the research that we are reading. So what are the goals for this presentation? Well, what I hope to do is not, first of all, scare you with statistics, but show how these statistics and especially descriptive statistics can really tell us a lot about a study and how those results are important, but most importantly, tell us how we can apply these results to the population we work with to improve our clinical practice, our professional practice, and so on. So what are we going to cover specifically in this presentation? First, I want to define what descriptive statistics means and how they can be utilized by researchers in the various studies that we read. Secondly, I want to go over some terminology related to counts and percentages. Simple terms, you probably have a good idea of how they work already, but I want to make sure you understand it from a research study, a quantitative study perspective. Also want to go over measures of central tendency. Again, if you haven't had a stats class, maybe that term is unfamiliar to you, but it just means the stats that are utilized to tell what the average is, or where do most people fall. That's what central tendency means. So I want to show you how we can, the terms that are used to measure central tendency and how those can be displayed. I want to understand the concept of frequency distribution with data and how those are displayed. So typically what we'll see in studies is a number of people are measured in some aspect, maybe 100 of them, and we could see the whole range of where people scored. That's the frequency distribution. How many people scored 1, how many people scored 2, etc., all the way through the range. The middle score in the frequency distribution is typically called the median, and the average is somewhere near that middle score, typically. What we're going to learn what frequency distribution means, measures of central tendency means, and how they're related. We'll look at measures of variability, which is, again, how dispersed are people in a measure around a mean. So is everybody really close to the mean, or are people spread out? That's a measure of variability. We'll look at this concept of a normal curve, which relates to frequency distribution, central tendency, and variability, and what that means in data analysis. And finally, we'll kind of change gears a little bit and talk about another way to look at data and compare measures, and that's called a correlation. So anyway, we have a lot to do. Let's get started. So descriptive data is basically the numbers about a population that gives us an idea of some aspect of that population, some characteristics at that point in time. So at the time of the measurement. So it reports on the status of several variables at a given point in time. An example in a typical study where humans are used, often one example is just a description of the subjects. You'll see how many men, how many women as percentages. We'll see their age, their average age, and their standard deviation of their age. So we get an idea how old they are. We may have counts of how many of this type of athlete, how many this type of athlete, another athlete, again, are in our sample. So they give us characteristics of the sample and provide us some insight into the population as a whole. So it allows us to evaluate, hey, is this sample similar to the population in terms of age, height, weight, and other interesting information, years played, and so on. There's a lot of different ways that descriptive data can be presented. We're going to talk about them here and see how they all show us, again, maybe slightly different things. Also, I want to show you how to read some of the tables and charts and the figures that you may come across in the articles that we read. Now, again, don't get overwhelmed in some of the mathematical parts or the statistics. We're going to be seeing examples of this, and I'll draw attention to a lot of these concepts throughout the rest of the course. So don't get too overwhelmed with the numbers, but it is really important that you understand, what is a mean, what is a standard deviation, and so on. So here's an example of how descriptive data can be presented. In this case, it's an example of counts and percentages. So again, anything that we can count and say how many people fall into different categories, or if we were to say, how many football players, how many soccer players, how many basketball players we had in our sample, that's called a count. Whenever you count how many subjects fall within a group or a particular category of behavior. Whenever we do counts, we can say how many people fall into these different categories. We can also do percentages. So this pie chart, pie graph, shows us how that's done. What we have on this table is, I guess the question asked was, what type of exercise do you like to do? And it was probably a survey question where they had a choice of cardio, strength training, both, or neither. So they forced everybody into one of those four categories. And this is what people picked. We see that 79 of the subjects picked both, 43 picked cardio, 29 picked neither, and 11 picked strength. Those are examples of counts. So they counted how many people said both, how many people said cardio. Okay, so those are counts. Percentages are basically just if we know the total of the subjects. If we add all of those numbers together, we come up with a number, and then we know by dividing the count by the total number of subjects, we get a percentage. So we can say 48% of the people, the majority, picked both. They do both types of exercise. 26%, or rounding 27%, picked cardio only. Only 7% picked strength training only. And then we had 29, or again, 18% of the population say neither. So again, this gives us an idea of counts and percentages, a really useful way to display descriptive data. This also shows the same thing, counts and percentages, but from a different perspective. Sorry, it's a little blurry. I stole it from the web. But what we can see here is blood flow under two different conditions. So at rest, the average person's heart pumps about 5,000 milliliters of blood, and it shows where that blood generally goes when we're at rest, with with the majority going to the liver, the muscles, and the kidneys. So that's where most blood flow goes, over 60% when we're at rest. When we begin exercise, our heart can increase blood flow by almost 5% or 5 times. So it can pump now about 25 milliliters of blood, and we see that nearly all of that blood flow is shunted to muscles because they need the blood and the oxygen and the glucose that's in the blood to fuel activity. And we see that the amount of blood flow to the other parts of the body decrease. And again, here the counts and the percentages become important, because while the liver maybe used to be 27% and now it drops to 2%, we can still see a significant amount of blood goes there, 500 milliliters. So the count is 500 milliliters, the percentage is 2%. But anyway, this is just an example again of counts and percentages. This is another example of counts being utilized to display data. So what they've done here is they've looked at all of the different injuries by body part in the NFL. I have no idea if this data is accurate or what length of time they did this for, but let's say it's for a season. And they measured how many different times each of these body parts was involved in an injury. And instead of displaying it just as a pie chart, which could be confusing with this large number of different categories, they did it as a bar graph, which is fine and just as valuable in terms of displaying the data. And we can see which, very easily it jumps out at you, which are the biggest bars, the ones where we had the greatest count in each category: the knee, the ankle, systemic injuries, and thigh. And then we can quickly see what some of the lower ones were, calf, hip, and so on. Kind of a strange grouping here that they split up some of these things. But anyway, but we can see, again, examples of the counts, or how many times each body part was involved in an injury. Again, just another way to display the data. And again, quickly displays what the important information is. And then finally, another way we see counts often presented is in line graphs. Line graphs are frequently used for changes over time. So if a measurement is taken over a length of time. So often we see this in training studies where maybe we're trying a new resistance training exercise or a new endurance training regimen, and then we measure a person's performance over time. You'll typically see these types of line graphs where we'll be able to tell, hey, if the line's going up, then it must be effective. Often there might be multiple lines on the graph, so we can compare, hey, what did one training technique do versus another? In this case, what I've given you are the average 100-meter sprint speed, fastest times by age for both men and women. So what we can see is, at the age of 35, the fastest sprint times for men are typically around 10 seconds. For women, maybe around 11. And then men stay relatively flat. But then once they get to about 75 or so, we start to see a steeper incline. When we get to 90, we see a very fast incline with, again, 100-year-old men. I assume this is the Senior Olympics, running a 100-meter sprint in about 30 seconds. Women, although they maybe start a little bit slower than men, they actually fare much better. And by the time they get to 90, they're still under 25 seconds. So, but again, what this line graph does, is it shows us how the data changes over time, and again, conveys it really well. You could overlay these two charts, which would be helpful, and that way you could compare where they both are. Typically they'll have them in different colors or with different symbols on them. But again, all of these are just examples of ways to display counts and percentages, not just numerically, but visually, to make it easier to understand what you're looking at. So I often am gravitated towards the tables, but also, more importantly, the figures, because they will quickly give you a snapshot of what a research study finds.